So we have sensors. You would have to remember name of sensors and all. Sensor is tackling with environment. Environment is analog. So the data which is captured by sensor is analog. It is not digital. Whereas this world of microprocessor is actually what? Understanding everything in terms of digital. So these are two different worlds. We need some help to get this analog data converted to the denary form or digital form or binary form. So that conversion mechanism is done by ADC. For example, let's say we are recording our voice and we are storing our song. In that case, your sound card would be the device which is converting your analog sound into digital. It's called monitoring. When we get to microprocessor, there's a software working and there's a preset value. Let's say हम इस AC को on करते हैं and we set the value 20. We set the value 20. In that case, this 20 is preset value, and we want our compressor to be switched on if the temperature in the room goes beyond 20. And if it is below 20, we want our compressor to be switched off. So while it is being seen, observed, it is called feedback loop, because whatever the data that is arriving from sensor is also being stacked, stored, collected, so that the progress could be seen. If you don't have previous data, you cannot observe whether the data is increasing or decreasing. It is quite necessary that every time you receive the data, you compare it with the previous data so that you have an idea that whether you're progressing up or going down. This whole thing is called monitoring, and keeping those values which are coming in is called feedback loop. Few of the computers just have monitoring. Let's say in emergency rooms of hospital, they are just monitoring vital signs of the patients. They're not acting. If the pulse down goes down from a particular level, it will indicate, either it will sound an alarm or it will blink the screen or whatever. It will indicate. So this is just monitoring, no actions. Let's say your car have these sensors which tell that how far you are from the object or the obstruction. If you get close, they increase the level of lights. So if the level of lights has increased to the maximum, yet you are going back and you bang your car against the wall, what sensors would do? Had there been a control part, this would have jammed your car. This would never let your car move a bit, a single inch. So this control part is when we have this actuator. What is actuator? The part of the machine which brings the change to the environment. What is the part of this air conditioner which brings the change to the environment? It is compressor. What it is? Compressor. If you walk through a door and when as soon as you get close and that door gets opened, what is the actuator? The motor which is opening the door. If you have got a Merc and you get close to another car, Merc will stop automatically. What is actuator? The brake. Get the idea? So actuators are working in analog world. If they're working in analog world, it means the decision which was made in binary should be converted back to the analog. What is conversion back from analog? It is voltage in the form of current. That's it. So that is done by what? DAC. All right. So this is monitoring and control. Obviously, it is not that just simple. You would have to read out the whole chapter to read it. So let's get to this second part. This is called bit manipulation to monitor and control devices. Now, this is particularly important. A few commands from the last year I added to it. This is actually assembly. You have to understand it in terms that, let's say there is a machine, you are controlling your using your computer. That reminds me of a task back in 2001. I was called by someone who were doing this project at Lexon Tobacco. They had one lab where every machine was doing different experiments over the made tobacco to actually judge the quality of the made cigarettes. There was a puffing machine. It had got 20 puffers. So they were just picking few cigarettes from the manufactured lot, and they were putting it into the puffers, and the puffers are just puff 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 puff. So they could see that how long that cigarette lasts and how many puffs. So what was happening that they had to actually stand in front of the machine to count the number of puffs. Well, it was like an incubator where you don't actually see this smoke coming out of the machine. Okay? So this machine had this ability to transfer this data through the wires to the computer. This machine has this ability to transfer the data through the wires to the computer, but since there was no program, there was no program written for that, people were standing and they were judging themselves and writing on paper. We were given this task to connect all these machines using RJ45, these LAN wires, cables, and to record it all automatically. Every machine had a manual given with it, and that manual tells that how to contact that machine, how to send a pattern of bits to that machine so that machine could understand what data is being asked and it returns the data. Then you have to catch that data back and report it on a screen or store it, whatever. Although when we asked them, when we gave proposal, they denied and we could not do that project, but yet the observation of that lab and all excitement attached to it was wonderful. Could not do it. So what I'm trying to tell over here, that every machine which is being controlled by computer has certain parts in it which are called registers. But you cannot, your syllabus is made as per the RISC processor, which are working register to register. So what you have to do, you have to get to that machine from that particular register. You have to load that data into your own accumulator, update that accumulator, and put the data back to the register. As soon as you will put the data back to the register, as per the condition of register, its binary digits, it will start acting. If you want to change a bit in a register, you would have to read the whole register to your accumulator, and then you will change it and put the data back to that machine. So that machine in your syllabus is out of question. What is required is when the data is arrived in your accumulator, how you are changing the accumulator. This is called bit manipulation. Let's say you want to shift this bit one position to the left. You want to shift all these bits one position to the left. What you would do? Do you have any command for it? Every single language has this command to shift shift the bits to the left. And we know that if in a byte we have saved, let's say 50, as soon as I shift all of the bits to the left, this 50 would become 100. And if I shift the bit to the right, this 50 would become 25. So when we move right, the number in the byte get reduced by 2, and when we move to the left by 1 bit, the number in the byte becomes doubled. All right, this is one encryption technique as well. Anyways, how to make changes to the data bit by bit is called bit manipulation, and that is what we are going to do over here. show understanding of how bit manipulation can be used to monitor and control device. If you want to monitor the device, you would have to read the registers to your accumulator. Once you read the registers to your accumulator, you can read them, you can change them and put them back to control that device. Is it understood? So let's see. Acha, I hope that you understand how byte addition works. It works column by column, bit by bit. That bit by bit tackling is called bit manipulation. Bit manipulation is not changing of the whole byte, it is just in one column. So we have these commands. These all commands work in columns. And it means that whatever the data that we are ending, A and DING ending, TK would have result as per the AND operation. So AND bitwise AND operation of the content of accumulator with the operand. Bitwise AND operation of the content of accumulator with the content of the address. This is exclusive for, this is OR, this is LSL. LSL means bits in the accumulator are shifted n places to the left. And LSR means contents bits in the accumulator are shifted to the right n places. This label is the label as we have these variable symbols. Okay? Let's do few of the question and then understand what is happening here. I have made these two charts here. This one is particularly important in the notes. It's a summary. Clears the value. If you manipulate your accumulator with and put all zeros there, this will clears the value. What does that mean? Let's just first solve one of the questions so that we have an idea that what we are talking about. You know what 2's complement is? Turning a number into a signed number. Turning one unsigned integer into a signed integer. That is called what? 2's complement. So if we have got a number with a sign in it, it is 2's complement. So let's say I have got 8, positive 8. How will I put it? 1, 2, 4, 8, 16, 32, 64, 128, minus 128. 2's complement says to the first one, keep it same and toggle the rest. And then if we add this, this would be plus 120. And this one is minus 128. So minus 128 plus 120 would become what? Minus ka 8. This is 2's complement direct method. I want to do it with 1's complement. What happens in 1's complement? In 1's complement, if I remember exactly, first you have to toggle the whole byte. Toggle the whole byte. So let's toggle the whole byte. You know what toggling is, right? Making zeros, ones, and one zeros. So 1, 1, 1, 0, 1, 1, 1, 1. How do we do it? Let's talk about it a bit later. And then add 1 to it. How do we do it? We'll talk about it later. Let's add 1. 1 plus 1, 2. 1 plus 1, 2. 1 plus 1, 2. There we go, 1. And then this is exactly what we did directly with 2's complement, isn't it? So two's complement, computer cannot do it. The two's complement method that we utilize is a trick. What computer does is one's complement. How computer does it? Let's say this plus 8 is placed somewhere in the memory at address 253. This plus 8 is placed at 253 in memory. It might be in my computer's memory or it might be the device memory which I am going to control. So first thing I would do, I will load it LDD from 253. So what is in my accumulator now? This one. Now I have to convert. I have to make every 0 1 and every 1 0. How would I do it? I would have to check this chart. Retains, clears, setting, retain, set, inverts the value. So which operation I would do? Exclusive for. Alright? ऐसा एक क्वेश्चन आ गया ना, परेशान हो जाओगे. So I will carry out this operation. Exclusive or with what? 1. See, inverts the value with what? 1. So I will be giving all ones means 127. All ones in a byte is what? 127. Or you can make it but you have to actually give this thing. What is this thing? Direct. Not direct, yeah, immediate. So 127. If you like it to be in binary, then binary 1, 2, 3, 4, 5, 6, 7, 8. If you like it to be hexadecimal, then and sign and FF. Got to remember all this. Whatever it is all ones. This would give us what? This would give us this. Now you know how to do it. And this will be saved back to what? The accumulator. Now you have to add 1. You have this command, increase accumulator. This increase commands actually add 1 to the accumulator. This will be accumulator increased and write back to 253. So what will be now saved to 253 instead of plus 8 would be, all right. So this is called bitwise operator. This is bitwise dealing, and the whole thing that you have used here is called the mask. What do we call it? This FF or 1111111111, a mask. Okay, what do we call it? Mask. So you would have to remember, you have to memorize this. How they actually using it in P3? Let's see. Acha, you might have such question in P4 as well. I hardly think that we would have a question related to this topic in P3, but surely in P4. This is important. This is from last year's P4, soon P4 pre-release. So these are what? Labels, as they were mentioned in the syllabus, labels. So load the content of A into accumulator. What is A? This LDDA. Add the content of B to the accumulator. Add B. You don't have to take care of this address. It is just label which will be used. Store at X. That's it. Ata. This is A plus B is equal to X is equal to A plus B. Check this. If X is equal to A, Then output character related to x, else a is equal to a plus 1. You are not just expected to do this bitwise manipulation, you are also expected to have this pseudocode, and you will be required to convert that pseudocode to equivalent assembly language code. Not just that. Okay? So I was particularly interested in one question which is related to bit manipulation. Yeah, this one. This is bit manipulation related question. Load the content of X into accumulator, LDDX. Bitwise OR operation on content of the accumulator and content of mask. There we go. This is your mask. ठीक है. Actually हमने यहाँ पे किया क्या है? See, programmer use bitwise operator and exclusive for to set or examine specific bits. Yeah, checking specific bits. Retain the value setting chosen bits to zeros and ones. We are checking it. What if I like to see if the fifth bit from the left in one byte is 1 or not? That is checking bit. तो हमने क्या किया और का लोड किया x is 10101111 और मास्क किसका अप्लाई किया और का. हम ये चेक कर रहे हैं कि क्या ये सेकंड बिट जो है वो 1 है या नहीं है. ठीक है. उसके बाद हम चेक कैसे कर रहे हैं हमारा कंसर्न नहीं है. हमने सिर्फ उस पर मास्क अप्लाई करके उसको स्टोर कर दिया y में. ठीक है. हमने मास्क अप्लाई किया. मास्क इज 01000000 और हमने वापस उसको स्टोर कर दिया y में. अब ये मास्क किस तरीके से अप्लाई हुआ होगा देखिए. So what is x? X is 1 0 1 0 1 1 1 1. What is mask? 0 1 0 0 0 0 0 0. What I'm trying to check, I am ORing. I'm checking if this bit is 1 or not. No, I'm setting. I'm not checking. I'm setting if it is 1 or not. If I'll be checking, I'll be using AND. So this remains same. This will be changed. This remains same. This remains same. Same, 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 same. All right. Only this bit is now changed. Okay. So I am using one bit to set the value of one bit. The operation was OR. What I have done, I left all other bits 0 and just that one bit to 1. When I performed OR operation, that one bit, if it was 1, it will remain 1. If it was 0, it will become 0. So I set it. So that is how we carry out these operations. Okay. You go through these notes. There are several examples there. Okay. Try understanding all these examples and past paper questions. Yes. Shift is not yet used in any past papers. But you need to understand that if it is shifted once, it is doubled. If it is shifted twice, then doubles double. If it was 3, it will become 6, and in next shift it will become 12, and in next shift it will become 24. It is not no more multiplication of 3. It is now multiplication of 3 to 6, then 6 to 12, and then 12 to 24. Okay. Do practice it, and if you have any other question, do post it on the group, zaconweb.com/a group. I'll answer, or someone else will definitely answer. But this